Hi guys, Paul K8IO here, and I'm going to talk about the bird Slug that's used in the 43 series Wattmeters. I had one that had stopped working, and I went ahead and taken it apart. I will put it back together to briefly demonstrate how it comes apart. Basically, this unit on this side, which is this part of the meter, let me show that, has the contact that contacts to your meter. This is the cover that covers the sensor element, and this goes into the meter. I have taken that apart, and here's what I've got. Okay, I've unscrewed it. This piece comes off. You sort of have to work with it to pop it off. It gets a little scary sometimes, but that pops off. Inside on this particular unit is a sampling element. This unit's range is 50 to 125 megahertz, and this is the sampling unit. This is the actual device that inductively couples, and capacitively somewhat, to the other unit. This resistor goes to ground and terminates the end of the loop. This is a loop. It's multiple turns. This goes through a feed-through capacitor. That's what that is. Right there is a feed-through capacitor. Up to the other side, which is a diode in here. Now, the way this thing works is to conduct the energy to the bird watt meter. You've got this little pin here, and this is how the energy gets coupled out to the meter. This is held in place. There's a piece of plastic in the bottom. I'm not going to pull this completely out because it's a real pain to get back in, but there's a piece of plastic underneath this to insulate it so it doesn't touch the metal and short out. This is the unit that transfers the DC energy out to the meter. This piece in turn goes back in the meter like this and seats down and will be flush, only it's not. So I need to work on that a little bit to where it is. I'm going to pause the video and pick up where I left off. I have now gotten this the way I want it, and when you're putting back one of these together, hopefully you can see in here, this little piece right here is raised, and if you look at the bottom of this, it has this piece right here is raised. So when you're putting this back together, also down in the bottom of this, if you turn this over, you'll have a pin protruding. More about this later. But the way the pin, where the pin is protruding, should have the raised piece of plastic. This then in turn goes like this. You then take these two little tiny screws and use your little tiny screwdriver to fit them down in there. Now, you'll say, hey, why are those two screws two different lengths? This one's a little longer. That's because I dropped one on the floor and I can't find it to save my soul. But this screw is, however, the right size and pitch to fit the hole. It's a flathead screw, it's not Phillips. So it's not perfect, but you know what? Means I'm not crawling around on the floor either. It's good to have a small tool set that allows you to work on things like this. Again, I'll take the tweezers and very carefully almost dropped that screw. Take this and put into that hole. I have great big fingers, I have big hands, and I gotta tell you, this small work is not what my hands are suited for. So there, we have the unit in place and tightened up. You'll notice on this side now, you've got the diode coming out here, and you don't have to worry about it touching. You do, however, do not want this to touch. Okay, we're pretty much done with this side of the element, and we can snap that cover back on. And that's going to take some effort to get it to snap back down in there. But once it's in there, it's in there. It's not going to come out real easily. Now we get to this side of the situation. This piece, you'll notice there's a pin and a slot, and that goes like that. That pin and that slot line up. Now here's something to keep in mind. Whoop. There is a hole right here. Okay, you'll notice there's a hole right here. This is where you're going to calibrate this little device underneath. So there's a couple things you need to keep in mind. First off, there should be a little insulating board, and it will go between the bottom of the adjustment control on the potentiometer and the metal, so it doesn't short out. Next step is to solder this to this, and what that does is that takes the energy from here and feeds over to here, which takes the rectified voltage and feeds out on the pins. I'm going to go ahead and solder this and come back. Before I proceed further, I want to correct a mistake I made. I made the statement that this diode does not need to worry about being grounded, and I'm wrong. It does. This should not touch the case, nor should this pin here. Okay? Shouldn't touch this pin or this pin to ground, and I'll show you why. Let me get the meter up here where you can see it. I've got it in the diode check mode, and this is a way you can test these pretty quickly to see if it looks like the meter's going to work. And that is by taking this. Notice I'm holding this pin to ground. Of course, if I touch it, I get no volts DC in the diode test mode. But if I go to here, I get 0.462, which is a common voltage you'll see a drop across the diode. Now if I reverse this connection and put the opposite polarity pin to the case, and this, you'll see that I'm showing an open circuit, which is how a diode should work. So just wanted to clear that up. Now I'll solder the calibration control. Okay, across. I have very carefully soldered the connection back. It's not the prettiest job in the world, but one thing you need to be very cautious when you do is that when you put this cover on, it lines up with a pin, and I don't know if you can see it, but this lines up so that you can stick your screwdriver through, and obviously this is a Phillips and you need a flathead, but you can stick your screwdriver through to calibrate the slug, because you certainly need to be able to calibrate it. Okay, next step is pretty simple. I should have a big screw here somewhere. Excuse me while I rummage around on my desk and look for it. But I'll line this up, make sure this fits down tightly. Eventually I'll stick this back on, keeping in mind forward and reverse power, and there's a screw that goes right in there, which seems to have eluded me. So, here it is. There it is, right there, big screw. That will go in there and tighten up. Let me grab a screwdriver. And tighten this up. And there you go. If you want to double check your work, you should show some voltage drop now from here to here in the diode test mode, I think. Never checked it this way, but let's see what we get. Okay, get the meter over here where you can see. Sorry folks, nothing. If I reverse it, okay, nothing. So I was wrong. You know, I better check this potentiometer one more time and make sure that it didn't quit when I installed it. Now I'm going to go to the ohm scale, and I should have a reading from here to here, and I do of about 14K, and that tells me that that should work. The problem I had with this meter was over the years these connections had corroded quite a bit, and it had become very unreliable, or with this slug. So I took it apart to clean it up and just give it a general once over. We'll pick this up after I calibrate it. Okay, here we are on test. I have an RF amplifier at 100 megahertz feeding a slug that reads 100 watts. And I'm reasonably assured that this is an accurate slug. Now, barring any sophisticated test equipment, aka a calorimeter or some other type of device, my methodology is going to be this. As you can see, I have success, and the meter that I repaired is reading about 80 watts. So I'm going to take this, and you'll see I can adjust this, go down in there, was a little concerned about that drop. That may have been the problem, is this potentiometer was dirty. So I'm going to work it back and forth a little bit so that if there is any dirt or other things in the meter, then I can rest somewhat assured that this meter is going to be accurate. So now I'm sitting at 100 watts. That agrees with my 100 watt, 100 to 250 meg coaxial dynamic slug. Okay. Showing just a little bit of let me dial that up. There we go. Okay. That's an honest 100 watts. I mean, I'm splitting hairs. The accuracy of these meters aren't that great. And I'm reading 100 watts, just a hair over. I'm going to call that acceptable. Now let's dial the power on up to 250. And I am in, by the way, a good 50 ohm dummy load capable of dissipating the kind of power that I'm putting into it on a continuous basis. So now we're reading 250 watts. I have a 250 watt slug here. Where'd it go? 250. Now this one's 25 to 60, but I find it's fairly accurate. And I am reading 225 watts. Based on the fact that I am getting an accurate reading at 100 watts, I think I am going to leave well enough alone and not adjust this any further. If I had an actual 250 watt slug, which I don't, then I would make the adjustment at full power. But I made it at 100 watts. I'm comfortable. This is going to give me a pretty good indication as to whether I'm putting out RF near that power level. Again, I'm reading just a hair under 250. The slug that's a little out of frequency range is reading 235. Truthfully, that's within the tolerance of the slug as specified by the manufacturer. Let me shut this test rig down and I will wrap it up. I'm going to follow up with something here. Really has no consequence, but when I reassembled the meter, I actually got the sample loop in 180 degrees out, and I'll show you why here in a minute. You'll notice the slug is pointing this direction. This is my source. In other words, it's telling me I've got reflected power. And you'll see in the other way I have towards the load no reflected power. What that's telling me is I have this backwards. However, if you lift this up, you notice the little hole right there where the divot used to be. So when I reassemble this meter, guess what? I am going to have to put it that way because I screwed up. I don't think it made any difference. I'm certainly not going to disassemble the thing and change it. I'm going to glue that right on there. And by the way, I watched another video where the guy drilled this out. I really don't know if that's necessary. I've had pretty good luck just picking these out. You might nick this corner up, but a little bit on them. I don't know if you look at this one. I did a pretty good job of lifting it up out of there without scarring it. You can see maybe here where I might have bumped it a little. But for the most part, I don't quite understand the need to drill this out. Personal preference. I wouldn't do it if it was me. Alright guys, I'm going to glue this back on with some type of glue in this direction and consider this a done project. Thanks for watching.